if you jump briefly, I will try to squeeze that one really fast. I didn't want to help you installing that one. I admit it's difficult. If you're running under Linux, it's extremely easy. It would be easy if I tell you, let's everyone has an account on Rackham or Alvis, and then we build there. But I can't guarantee that one, and things are changing faster than I can actually promise. In reality, it's better to find a way where you can actually build with elevated privileges. I will mention what's the problem with that. The latest versions of Singularity and Apptainer, at that point, that's their kind, we can call them equivalent. They can build without elevated privileges, but they still need something behind the scenes. You haven't seen that one. During the installation, they do changes that allows you to do that. Now, if you're on a restricted cluster, which doesn't allow these tricks with user IDs, etc., it will just not work, or partially. So what I'm saying is, like, if some of you are building on Rackham or Alvis, I have tested simple cases, but I'm not betting, but I'm saying that if it was the case, they wouldn't ask for sudo. So not building with sudo presents some limitations. So you might expect problems. So this is where I'm aiming. You better have a solution where you are running everything with sudo. But for the purpose of this workshop, I think that will be perfectly fine if you build on Rackham or Alvis. The other centers don't have, or at least I'm not aware that they have Apptainer or Singularity that allows you to build with fake root.
in the case Apptainer is installed and one can use a fake root, but as you mentioned, for simple cases, it works. Yeah?
Okay, so that's good. I have collected, probably it's at that point somewhere else. No, that's how you install it on your computer. If you go on the building with fake roots, on the bottom, I have collected information that I have found in different computer centers. So that will be HPC2N. That will be on Alvis, PDC. Keep in mind, if you're running on PDC, I will mention that one later. The containers look slightly different, or they have a different building regimes. So I will show you that one in another context, but this is the time when I say, okay, this is the way how you build containers for that there. So for details or something that how to use it, you better ask the centers themselves. It's slightly beyond what I can control. If you have chosen these options, keep in mind, in most of the places you have a small home folder. On Rackham, that will be about 32 gigabytes, which is not much. As many of the tools that you can imagine, cache and builds, temps, folders are stored in somewhere in your home folder, and that fills really fast. Even for the exercises, you can exhaust the space. So define these variables, which points or forwards this Singularity cache dir and Apptainer cache dir to folders which are somewhere in your project folders where you have more space. That makes it also a bit slower, but at least you're not running into weird problems where you don't actually realize what's the problem. The errors are not clear. You're running out of space, but the errors doesn't say so. They might end up printing out really weird errors. If you have questions about that one, let me know. Just out. Then I will mention that one because I just have few words. And the original developers, that one was Silabs. So if you jump on that, it looks slightly different because I already logged in. But this is one place where you can build containers. It looks really nice. I haven't used it for a while, but you can see that for free, I can get 11 gigabytes of storage where I can share containers. I have something already running, but since it's free, you can imagine that you have something like 1,000 maximum build minutes, so within 30 days. The building machines are small, so if you're aiming for R, you might experience some problems. While we're on the subject of R is particularly nasty. If you install packages, some of them might fail, but because the way they're installed, they don't trigger the error on the upper shell. So Singularity just peacefully continues building. And if it's a long build, it gets lost. And it successfully even wraps a container and the container doesn't work. So keep in mind, that's something to look. Even if the container runs, R is usually the worst with this respect. It might not be a healthy container. So if I believe there was an easy way that I can actually even start, I don't see the console now. So it's slightly different. Perhaps this one. Yeah. You can copy paste here. Submit build, it will be built on the cluster, etc. I will not go in more details about it. I will tell you what I've been using that one. In the early ages, when I needed to produce a container for a colleague of mine, or it was a support request, we could run into a situation where I can build it, but whoever else I'm helping can't, or they don't run. So we're in the situation where my container is different from the container that is built somewhere else, etc. So that used to be the reference point where I'm saying, okay, this is the official developer's resources. If I build it there, it is what it is. It's a reference point. It's not because my computer is set up in a different way. It's not because somebody else's computer is set up in a different way. That's the reference. So even if I made a container on my computer is perfectly running, I was always building it there, and this is what I was sharing. So if there are some complaints, it's like a broken TV it's your TV that is broken, but not mine. Otherwise, I had another favorite. I will go a little bit further. It was the project about very similar to what you have for Docker Hub. You can link to your Git repository, and as soon as you push a recipe or definition file, that will trigger action. It will build it, and it will expose the container so you can actually download it. It was just perfect. Of course, it was the problem is it was running out of funds, so the project is dead. I will just mention it. I will not go further, but this was an excellent tool, and some of my recipes that I share without comments are still adapted for how this was working. So they are named like Singularity with capital dot and the name of the tool, because this Singularity registry was taking the name and the extension for the name of the container, etc. But that one is fixed, so that should not affect anyone at this point. Now, I really want to stop for a break, but the way we will do it is let's jump on the first step and try to build the first container. I will post the link. So we try to build. Then I will wait for you for a while, and then we gain more time by having a small coffee break. You can ask questions during time and everyone can catch up. But what you want to do is create a file on your computer, on Raccoon or anyone else. So take your time. This is the easiest way to make sure that your Singularity is running, or the setup that you are running is running. The usual you can click here, you can copy it in the clipboard. I use VI. Okay, I have a leftover from an example later, but I will call that one. It says def, and I will paste. We will start after the break. I will explain every line, and there are more, but this is what actually, if you follow the documentation, that's how Singularity starts. So what I have is, ignore the other file, but I have this file now. I will use another fancy way to show you what it looks. It doesn't look fancy though. So that's a definition file or recipe. I will mention it sometime. You can consider it equivalent to Docker file. That's the same. That's what it brings, and instructions how to build a container. If you look further down, you want to run it this way. So let's run that one and see if it runs for you. Right. So I'm running that one on my computer. Okay, I'm cheating a little bit. It's a remote computer as well, but it's a Linux machine, and I'm presenting on a Windows machine, just to get the best of the both worlds. Zoom runs better on Windows. Don't want to stretch Linux on that. Anyway, it says that build complete. If I list what I have in the folder, I got a new file. If I list it size-wise, it's 82 gigabytes. The reason is you've seen, if you're familiar with Ubuntu administration, there was a lot of packages, and actually we installed 3 packages, but it installs all the dependencies as well. So this is what I like. I'm familiar how to set up my computer. I know that apt-get or apt file package manager will manage the trivial dependencies. So I'm actually confident that if I install these 3 packages, it will install all the dependencies in the libraries, wherever it is, with a little bit fiddling, not much, I should be able to have something ready. So what is in the manual, we say, let's try it. And this is exactly, I mean, you notice it's green in this case, but it has executable attributes. So that's an executable. If we run it, you will get slightly different outputs. So what we've been running is, I will spoil it a little bit. We set at the end, run that one. If I don't provide and I don't tell anything, I mean, in Docker, you can you have also, if you just run the container, it has by default what to do. That's the equivalent. It says run this script. So if I run the container, it will start fortune. It will pipe the output to COSA, and then that output will be piped to low-cut. And that's the result. That's like this. And because the fortune is generating random text every time, if I rerun it, I will get slightly different. Well, slightly, actually, almost. The text is complete. Right, before we get to a break, any questions or problems running that simple example? Okay, so I'll try to slowly continue. What you've seen is that we had a couple of commands that we passed to Singularity, and Singularity was able to build magically as a black box, a container. I'll just go through the lines, which sometimes looks obvious, but then I will try to comment. The first one says that from where we are going to make the first basic or what it will be based on, or the source rather, because this is we will use Ubuntu version 16.04. The notation is like a Docker exactly. This is the image and this is the tag. In this case, it's a version. And we say that we will fetch the source for that image from Docker, which refers to Docker Hub. So these two lines, there are some must-have. Is essentially you need to have a bootstrap, where is the source, and from that source, what to get. Probably in better words in the documentation. A keyword with a %post, which is strange, sounds like a postscript or something like that. But this is what it will be executed as root or while building the container. There are other commands, but they are not here yet. So during the whole workshop, I'm using Ubuntu as a base. It seems to be popular. It's not the unique, but then you use the apt-get package manager. You need to first update it. If you're familiar also with Docker, you know that if you try to install packages, it doesn't have the indexes. It doesn't know what's available. So the first one will bring fresh indexes of the packages available on the distribution. Keep in mind -y. If you do that one on your computer, if you skip -y, it will ask you, well, not for update, but it will ask you, do you want to do it? While building the container, you don't have interaction. So this is the first problem. Everything you build, you have to be able to do it non-interactive, which means you need, okay, for a beginner, that might be, if you're used to copy-paste or using graphical interface, clicking with the mouse, this will not work. Everything happens on the command line. Again, I don't have to actually excuse that one. That will be the same case for Docker. That will be the same case for Conda, things like that. So -y is to answer yes on the question. So when you want to install these 3 packages, it won't ask the question, it will just install. That is for that section. Then there is a section which is an environment. We want to actually push or define an environment, something like bashrc. That's something we will do in bashrc actually. Is saying that if we run this environment, we want to put, and that is actually pushing the localization to basic. I forgot what is the main. Every system has at least that one. So when you get Ubuntu, there is no guarantee that you have Swedish localization, UK, or any other localization. So this will save your troubles by running a container that doesn't have the correct localization. Also sharing with international. It could end up with any other computer which will just struggle. Now, many of the programs are designed, at least the system ones, if they don't find the localization, they will fall back to that one, but it will prevent a lot of mess. This will save that hassle. So most of my containers, I probably close to 100%. I always have that one as an environment. The other one is, it is on the official documentation example, so I copy-paste it. Apparently, one of these programs is installed in something which is USR Games. If you try to install that one with a newer version of Ubuntu, it doesn't go there, so you don't need even that line. But I stick to what is available online, so avoiding confusing anyone. This means that when you run the container, in the path while you're in the container, this will be in the path as well, USR game. So anything that is in the game usr/game folder will be available on the command line. I just want to see what's on there. Don't use sudo on Rackham. If you run it on the login node, then I mean, you will get an email. You can't do that. We can try to find a solution during the next break. But until then, and the last line is, I didn't want to do a parallel with Docker because some of you might not have Docker, and that's not about Docker. It defines what will be run by default if you execute the container. And this is what we've done. I'm back to my computer, or yeah, that's in my computer. If I install run, it will run these commands. So I have it on my local computer. I will illustrate because I don't want to. But I say, if I run fortune, I will get a text with a quote. In this case, Mark Twain. If I run it again, I will get something else. If I pipe that one to say, I will get it wrapped in cow-looking cartoon. And I can further make it colorful with. So, not a brainer. The idea is that by running the container, I already set what to run. Now there is really easy way to say that you want to have parameters and etc. But we will come to that idea as well. Everyone was able to run that? Okay, let me few more words. So remember I told you what are the source, and in this case we start with Docker. I think with few exceptions, all my Singularity images or containers are from Docker. I quite often, I like Ubuntu because I work with Ubuntu, but again, with few exceptions, I've been using CentOS. If there is an example how to install it under CentOS, I will not. It doesn't pay off to get creative unless it's really important. No, on Rackham, you don't have that file. I see it on the, exactly what I'm saying. I just illustrated it on my computer, but I have installed these packages as well. So this is exactly, you don't have that program on Rackham, but having the container, you can have it, and I can show you how to run, but that will be the next step. So you can have access to each of these fortune, say, lowcat, and anything else that is available in container. You can actually start it and use those as well. I will show it. So this is better actually, instead of going linear. I can say Singularity, and in a similar way to Docker, I say that I want to get a shell into this container, which is C. So notice it might be slightly different, but my prompt became Singularity now.
Okay.
Now I can show you also that all of a sudden I have Ubuntu 16.04. This is what I really like. You can do the same with Docker. I will keep repeating, you can do, blah, blah. But I will reach a point where it's like, this is devastating under Docker. Or, so now I'm inside, I'm not saying a virtual machine or anything, but it's an environment. It is a setup of Ubuntu 16.04 with 3 packages that I installed. So let me see, just to illustrate, if I'm on Rackham, here I'm on Rackham, and local was not there. There is no such command, but I can do this one, shell, and now it says Apptainer. And look at local, Come on. So, what? Lolcat. Am I? Lolcat, of course. And that one waits for, but I can ask which, okay, I will get outside. Now I'm on Rackham. Which Lolcat? Okay. There is no such. But if I jump into the container, you see, it is actually a complete Ubuntu system that I'm in a new system. If I look how the root looks like, of course, I don't have even that one. Come on. Those are not the files that you will see on Rackham. There is even this file. There are some nice things that you can recognize if you're careful. SW is there. All the software tree on Rackham is available in the container. The Scratch is, which is the local hard disk, is available. And you should be, you bet also the home folder is available in the container. I will show you what else is available. So inside the container, now I have programs that you don't have on Rackham because I'm inside this environment. It's very similar to activating a Conda. You activate Conda environment and you get the packages that are installed in this environment. At the same time, you see the system, of course. In this case, you don't see the system anymore. You're isolated a little bit. Okay, so I can do Fortune. I think Fortune is also not available. I'm back. Let's say Fortune. Yep. So I have tools that are not available on Rackham, and I build them actually from scratch. And if I'm familiar how to do it on my computer, there is a good chance I can do that one to run on Rackham without even asking for support, if you know how to do it. So let me see. I see the first R question coming. I will, this is complicated. A colleague of yours asked me in an irrelevant, okay, he contacted me in another way. So he is participating probably. And bioconductor is in there by chance, but that needs a longer discussion. So I'll come to that one as well. Okay, let me just squeeze a few more words and then ask you again for questions. But here you can briefly see more detail you can find on the original documentation. Always refer to that. But here I just for the sake of the what I can bring easily to understand is the header. You can ask from Docker the way we did it. That will point to Docker Hub. Library, that will point to the Singularity library, one of them, and shub is, I think, is the dead one. Something that I noticed, I'm not entirely sure, but it seems that Apptainer, because that is the free alternative, they don't have access to the library anymore, or something is fishy there. I haven't investigated absolutely everything, but it might differ. And again, you can have local image that suggests that actually instead of looking into the net, you're looking for a local image for your bootstrap. That one I have never used. That one occasionally. Docker daemon, I will show you a trick. That one I have no idea. I haven't tried any of the others, but they are there. From is what I told you. It's in the case of Docker, you specify the source, which will be the Ubuntu image, and the tag, absolutely the same way you do it with Docker, with the column in between. So that shouldn't be a problem. Post section will contain the commands that you want to run to build your container. I will say it now, I will mention it later. For unfortunate for me reasons, or I absolutely agree with the developers, what you are running in this section during the build is not bash, but is pure sh, or what was even called there, which means that some commands that you are acquainted with under bash will not work. I will just bring it. Usually there is a good overlap, so this is not a surprise. It is just when you hit it, you can't possibly imagine what it is, and that's one of them. And the easiest to hit is if you have an environment that you want to activate. Usually in your terminal, you say conda, or you have source something environment. If it's properly set up, you just conda activate, etc. But the first line to be able to use conda is sourcing the conda environment setup. So you type source and you point to the location of that file. Bash have source, but not sh or dash, so I'm not sure what it is. Instead of that one, you have to put dot and the file. And the file is in bash, so it doesn't work. So I'm just pointing it. Keep it in mind. In the most scenarios, that will not be a problem. If you get weird errors, that will help you why it's not working. I'll bring it back when it's important. Run script is what you're saying is, if I start a container, this is what you want to run. There is a way to say, don't care or don't use that one, but run something I want. And I will show you how easy it is. It's just, you end up by adding 2 extra strings in front or command, which is Singularity run, and then you say what to run. But later on that one. So here you can go to the online documentation, all the sections explain. And I'm giving you a simple example, which, believe it or not, I can easily prove it. It is, I'm not a tech guy or Linux tech editor, what you will call it. It's not an editor, but it's a publishing format. So quite some time ago, most of the publishing houses were not accepting Word documents. They wanted the source of a tech document. Nowadays, they're more acceptable. But I have collaborators that are still building their publications in tech. And as I said, I'm not a tech guy. But if I'm collaborating with professors, usually I'm the one adapting. It's difficult to force professors to adapt to your style. And the most common problem I have is I'm missing some of their, what you will call it, styles, or anything. But under Ubuntu, there is something that you can say install TechLive full. It's huge, but I don't care. It is compressed like 2-point-something gigabytes, but I have an image. So if I get the source from my collaborators, I can build it, I can collaborate, I can change it, everything, and I don't pollute my system. I don't want this hanging around, because updating 4 gigabytes when TechLive gets updated, it's just slowing down my updates routines. This stays there. I probably use it once per 2 years. I'm happy. So what you see is like, I use Docker. In this case, ask Ubuntu, and I look for the latest LaTeX, because probably my collaborators, they're using some version that is, they always claim, oh, you need to have the latest. So this is the latest tables, probably not the bleeding edge LaTeX, but is in the latest, not even long time support Ubuntu. So I get quite decent one. Here is a small trick that I can sneak in. The apt-get or APT manager accepts an environmental variable which says Debian front-end non-interactive, which says, I'm not around to answer questions. So the usual is here, the apt get, I'm saying, okay, yes to this upgrade, yes to install TechLive and then clean everything. But TechLive pulls also localization for the time formats, because in editing you can specify how the date looks and things like that. And at that point it asks you, where is your location? And you have to say Europe, then Stockholm, and no, that doesn't work. So having this extra line instructs most of the Debian packages that are maintaining one of these systems. There is no one to answer your questions. So go with defaults. You will end up with GMT time, which is Greenwich time, some UK, not even UK localization, but you get at least passed by these questions. And I will not ask you to do it because that is so large and it takes a lot, but I'm just telling you how easy it is to have. And what I'm doing is, usually it means that I need tech around. I will start bash with parameters I want. And I have that one in my own collection. That one is in SP, Singularity, and then latte, or what is it? TechLive. Now I have a computer, which is probably, let's see, I have no idea when I did that one, but okay, that one is old now. My system is newer than that one. And when I did it, if I check the date, that was newer than what I had on my machine. But I have tech, Debian, whatever. I can just show you. If I get back, I have no text, but tech. I have no tech. And I don't care. It is something that I'm happily using in a container on demand. And if you were careful, or you're watching YouTube, you can always see what else I have. So it is give you an idea. Quite often, I have old projects that I've been asked from collaborators or even from PhD students to reproduce plots. And this is dating back 6-7 years. And I built different new plot versions because they're not backward compatible. I just briefly check during which era was done. So I know that it was Ubuntu 16 or something, then I can pull the new plot corresponding. And I can reproduce my plots. And I say, okay, here it is if you want to do it. If this is with your new data, this is how it looks like. But if you want to do it, make it running on your current Ubuntu, here is a reference point. But I have literally spent 2 or 3 hours trying to bring something that I plotted in version 4.6 with the latest 5.4 on my computer before I just said, why this is so easy. It takes no time for me to bring new plots in Ubuntu, probably 16.04. Problem solved. They look identical as I've done them that many years ago. I have some JMO. I have what is it? OpenBabel. I have RStudio and RServer. You can already sense that I've been tortured to get some solutions for that one. I have TensorFlow. I will show you that one because some of you want to solve problems running machine learning, artificial intelligence, and how to get the NVIDIA cards. I will do that one. This is scan recognition software that was, I can actually install the development version without messing my current setup. So I get something which is not in the official channels. I can install it in Ubuntu system or operating system. I can use it in this container with the files I have in parallel with the version I have in my computer stable. But it's on my computer is version 4. The development is 5 point something. It's like, and some other tools that I'm happily using in isolated environments. Recently, I was able pushed to use GCC 4.6 even for testing purposes. Yeah, you can have that one easily. And this is just a simple pull from Docker. I've done nothing, just a single command. I will show you that one as well. Right. While we're on the NVIDIA, let's wrap that one. Just to show you how powerful this could be. I have collected that one here in the first steps. Is actually the last step. I will paste the link. And things are so dynamic that actually I have a snapshot of the page, how it looks like. So when I talk, I know what I'm talking. But NVIDIA got sick of people trying to probably complain that they can't set up certain environment. I've been in this situation where my colleague is developing a tool for TensorFlow and take him, literally he is the developer, 1.5 hours to make it run on my computer. At what point I just convince him, okay, this needs a better solution. So now he has a workflow which builds a Docker from GitHub as soon as he pushes his program. And that Docker is compatible, so you can just pull it with Singularity. We will do that one later, and actually we can do it now. And it is compatible, so Singularity on the fly converts the Docker image, and you can use it as a Singularity image anywhere you want. This is the same situation. NVIDIA provides Docker. If you follow the links, I will just open it. This looks really awkward, but I think it's because the screen is small. Yes. But the story is, you have a machine, virtual machine, let's be honest, that's a Docker 2004 Ubuntu. That comes with Python 3.8. You get CUDA, that version, plus NVIDIA, NCCL. You get so much tools that I've been trying to install fraction of that one, and it could take ages, and at the end you're vaguely sure or unsure if this works or not. If you look, you even have a Jupyter notebook. It might not be the latest. You have a Tensor board. You have all the tools stuffed already. This is huge. If you're wondering how large it is, probably it's that one here. Or let's don't speculate. I can go on Rackham, and I have put that one. I will show you. Here, I have a few small collections. So that one is that image, and that is 6.5 gigabytes compressed image. If you uncompress that one, that's roughly equivalent to 12 gigabyte setup. But if I use that container with a colleague that uses the same container, we are running the same setup. Now, there are some precautions, but we are very close to identical environments, and this is brilliant. If you see what I've been showing that one, that was a solution for a colleague or a researcher running machine learning on Bianca with sensitive data. Now, the story is that you get that one for free. Literally, I'm telling you, a single command, if you look, you run this command. For those that are using the VM, I've done it, it's cached, it will be fast. But it takes some time to download this, like 10 gigabytes. Well, it's also compressed, so you get less. But it takes time to download, uncompress, and compress it back to Singularity, and you end up with 6 gigabytes. It's a lot of stuff. But that colleague needed a different version of PyTorch. So they changed that one, and I'm showing how you can do it at the end. You say bootstrap Docker, you point now to that image which is available. If you're careful, you will see that's not Docker Hub anymore. This is just the protocol to use to communicate, to download that Docker image with this tag. And that one is NVIDIA, I forgot CR stands for something. So they're actually providing their own Docker images. And I'm saying on that image, I want to install PyTorch the usual way you will do it with pip install or something like that. Now, the story is that if you read it carefully, I will make the message now. It's like, if you're back here, the original supports pretty much any CUDA or GPU that is available. Well, not the ancient, but most of them. If you install with pip, the PyTorch comes with kind of the last 4 generations of GPUs, NVIDIA GPUs. So be careful. Nothing comes granted, but that's not a problem of Singularity at this point. It is a problem of what is in the Python PyP repositories. So if you're curious to run, I will just demonstrate it. Now, I can't do that one on the compute node because that one doesn't have a GPU. But I can abuse my kind of rights that I have. I can sh to Raqqa, and I end up on a login node, Raqqa2. That one is not for computational purposes, but just because many users are using graphical interface, the login node has a GPU, which is perfect, because then if I go there, I have this container already downloaded, so you can use that container on Raqqa and Bianca already. So what I can do is Singularity. I think I can just PyTorch. Let's see. That will give me, yeah. I think I'm in a shell. It says Singularity. Because it runs my basher C, it tries to load the module system, which is, nope, you can't do that. Inside the container, all of a sudden, it doesn't know anything about MPI, doesn't know anything about slur, doesn't know anything about the module system. You can fix it, but that's not NVIDIA job. So I'm in a situation, okay, it's an error, but doesn't matter. So let's follow what I have. You can try to start Python 3. And as they promised, we are running Python 3.8 because that's an Ubuntu 20.04 machine for setup environment. At that point, I know that I will fail, but let's do it. Import torch. Okay, that's fine. Magically, it's there. Is it CUDA available? False. Ooh. Oh, come. Okay, we can't start it this way. So I'm back from Python and I'm back out from the Singularity. The way to start it is Singularity. We do the same shell, but now we need to say that it needs to communicate with the NVIDIA drivers, and that one is NV. Okay, if I run, notice I didn't get errors like before about the module system, things like that, because it didn't actually go through my basher C, I suspect. So now it doesn't even care about module system. Okay, we do Python, back. We do torch, there. Is it CUDA available? Oh, all of a sudden CUDA is available. Let's see if we can get even what is, okay, this is just to confirm that we have capability to work with this, and I will check it actually. What is this? There was a way to check which is the card. Where is this? I want to see NVIDIA. And that one was done by that one. No, that's dark list. This is strange. I done that one yesterday. I don't understand why that doesn't work. I'm missing something though. You will see what's available. I don't understand why I don't get now I can try that. Anyway, let's see. I'm back. I can try to run this one actually. That is actually in the, let's try it. I will jump inside the container. This should print everything. Now I know. It was a warning, that's why I didn't get it. It just says that our GPU is really old. You can't do much about it. Okay, I will skip that comment. Do you have questions about this? Because that was actually jumping a little bit. Okay. What we will do is something. We go to the next step. And then I will give you a head start in some sense. Yes, HackMD. Is it possible to build Windows and Mac OS paths when building in a Singularity image? Paths. That brings me to another problem with Singularity. So Windows, one of them is having the wrong notation. The slashes are in the wrong direction. But that's not the problem. The problem is perhaps while you're inside the container, you're running Linux. So Windows, a major difference also is like it will be case sensitive. So if you have somehow accessing files to Windows and they're, okay, that's the opposite actually, Windows will have problem, Linux will not have problem. I think Mac OS is also case insensitive. If I properly understand the question, to bind. Yes, then I know what you mean. So the story goes a little bit further out. If you use, I can talk about Windows because I'm not a Mac user, but not even Windows in depth. But if you use VirtualBox or what was the other one? Well, let's stick with VirtualBox. VMware was the other one. You're completely encapsulated. So unless you expose folders from the host to the guest, you don't have access to the container because the container is also running in this Linux environment. Vagrant is actually a command line to start and boot this machine. So your virtual machine first needs to get access to the Mac or Windows. So that gets complicated. Usually the easiest is actually to fetch your data. That's why, for instance, you're trying to fetch everything from open sources, but we will get to the point where your colleague is asking. You can't get it anymore. You have a licensed software, or it asks you to put a password or a graphical interface, confirm license, and blah, blah, blah. You get the file, but then you need to push that file into the container. So I guess that's the problem. B argument, which is binding, yes, it will bind what is available on the host or on the guest, if it's a virtualization. So unless you have that one exposed to the virtual machine on Windows or Mac, you can't bind it directly. You can't jump outside this virtualization, which brings me back to Windows subsystem for Linux. You can relatively easy, perhaps not easy, let's say, there is a way to mount CD drive, but there is no easy way to mount SD cards, which is ridiculous because that was what I had. I don't have external disk or things like that, and I had my files on my SD card. That might be probably fixed nowadays, but yeah. If it resides in C documents, you can go that way. Let's think about, we can try it. I haven't tried in DSL, you can, but you're looking for troubles. I will mention, not now, later I will mention what is the other problem. But for binding, that's the only one. There is another problem with paths in Singularity, which is not obvious. Okay, then I stop with that one. And what I want you to do, and I see another question. If I'm exporting def with local installation with other using the container, yes, somebody is going ahead, but when you put the file inside the container and you share the container, the files are inside the container. So keep in mind what you put in the container. Try to avoid putting licensed software or the licenses for the software, because that way you distribute the licenses. Also, some of the license or the license agreement might not allow you to distribute the source. So what you would do is you bring the source of the container, you compile your program and delete the source. You are left with, so what you're distributing is the compiled version, but make sure that you comply. If you do it for yourself, you can do anything you want. I mean, this is still will fit the, we will get to that example. But what I want you to do, and at the same time, we try to have a break, just pick something. I'm giving you an example, and I will tell you, don't pick the example. ParaView also builds a large container. Grab some, get something smaller, like NuPlot, if you're familiar, Grace, Blender, Pavlin, Rasmo, Gromax. Don't go with OpenMPI. But you can do that one, actually. You can install Gromax provided by Ubuntu, which is not the latest version, but it counts. You will get even the MPI implementation and things like that. Or just try something which you want to bring, for instance, to a computer center. And the idea is you build it, and then you want to bring it to your computer. It could be at HPC2N, it could be Dardel, might be a problem. It will be a problem, but try to run it in another machine. If you don't have a good idea for a tool that you want to install, just use the local, the one that we built from the first step. Transfer it to another machine. I know why I'm telling that. If you're using Vagrant, everything what happens in building is in a virtual machine. So that file that you got at the end, the easiest is to secure copy it from that virtual machine to a computer cluster, or even, you can't secure copy to your machine. So Windows and Mac setups are not perfect. I have to agree. The question, when you create a container with CUDA support from recipe file, is it expected to have the driver's device support on your local machine in which you build it? Yes. You can have CUDA, but CUDA should be, the version should match the drivers. That is, unfortunately, you can't get away with that. So kernel is easier which is usually most of the features that you will have in the container will not depend on the kernel. Of course, I have examples where I can immediately tell you. One of the tools is this one, Grace. If you install Grace in a Ubuntu, 20 is enough, or 22, it won't work on Raka, because that tool is using GTK version 5, which some of the libraries, to speed up and make it faster, they make call to the kernel. A function that is available in kernel newer than 3 point something, or let's say newer. What we have on Rakam is Asian kernel 3 point something, and that function is not there. So essentially you end up with worthless container to run on Rakam. So if I fast forward, probably it's on that site somewhere says. Nope. One way to circumvent that is, let's say, a year ago, that was difficult to find on internet how to do it. I have the fix on the web page, we can find it. Nowadays, it's easy. You Google, once you get the error, you can easily find out how to fix it. The other one is, if you know that you will have kernel calls, you will want to build your container with older distribution, which is Debian something. I can find it somewhere on the web page. I explicitly say which Debian and Ubuntu are such that they don't have libraries that call kernel functions. So you can avoid these problems. But in general, that's the other problem. If I have a software from, I want to give you a break and I want a break. If I compile from source and I have a new machine, and for instance, it has AVX3 or some of these fancy features, they are not available on Rakam. So that won't work. So you need to take care of that one as well. So, and this is essentially, you have a binary which is incompatible with the hardware. So again, just to defend Singularity with this respect, you will have the same problem with Docker. If Docker was compiled for architecture for a CPU that is not supported, then it won't work. So nothing unique with Singularity. Just keep in mind. Now, if you run to Ubuntu, it's the common is some vanilla. You don't get the fastest and the best optimized binaries, but they run at like 95% of the efficiency, things like that. So they're most of the time, if you're not after the last bits of performance, they're perfectly fine. If you want to recompile, keep in mind that you might actually specify the platform to which you want to. And while we're on the CUDA and NVIDIA, if you try to compile PyTorch, that's the same story. PyTorch, when you compile it, it will look during the compilation what hardware you have. Now, on my machine, I have a small GPU, which is also old. It will build for that GPU. Once I move it to Rakam, they have, I mean, on the compute nodes, I have newer GPUs. It won't work again. So literally on my computer, I have to specify, okay, ignore what I have, build for this platform or this GPU drivers. And this is the same story. And that's why NVIDIA provides for pretty much all the available GPUs, or let's say not the ancient ones, but. Okay, so let's have a break like 10 minutes till 35. Try to build something and run it somewhere on the clusters. If you don't have, experiment, bring some questions. And we're running slower than I'm expecting. So the question is, okay, let's, after the break, see if you have faced some problems. And then I will skip that part because it's a little bit more complicated. And I will show you easier how to run. I've been already showing such stuff. And then I'll try to escalate it really fast. Def files are called, well, if you look on the net, they're defined, they're called definition files quite often. In my mouth, quite often it comes like a recipe, because that's the easiest way to say that this is the recipe we use to build. What else you can find it? If it's a lingo or jargon, if you talk in terms of Docker, people just say Docker file, because the default file that when you build Docker is the Docker file in the current folder. It's like make file and things like that. But in case of Singularity, it doesn't matter. It could be anything. It's just def is something which is accepted nowadays. It could be anything. I will show you then, just to fill the gap while we're doing it. I have something which is count. So this is old, or things here like 2 years. So if I look back, I call them like singularity.unitm, because some times ago I was using this build service that will look in my Git repository. And if it finds a file which starts with Singularity, it will use the extension to name the container. Now that is dead. So what you will rather find is my latest, and this is probably, I can bring that one to the attention of whoever asked the question for the R. This is a real case, and I'm not mentioning the name, but it's not exaggerated. You can have a setup with R, and you need something specific, which means that you install older version of packages, which your colleagues are not eager to do because they will break their own environment. The reason is because it's not trivial in R to have different environments. For Python, that's easy. Julia, it's easy. Rust, that's easy. Conda, that's easy. So it's obvious. R, they have a solution, it's just not that common. So the stories comes even with my colleagues, the one that I mentioned that takes 1.5 hours to make the same setup. But anyway, if you look here, it's a case that we solved a couple of days ago, 3 days ago. So that one will install, it's based on Ubuntu 24, just because some of the dependencies require older GCC. You can look on the newer one. So this one is fully blown. At that point, production kind of ready solution. You will have a lot of libraries. This is the next example that I wanted to show you, that if you use this Vesta GTK3 example, that's not enough, because you install something not from APT, and that doesn't know how to start APT and install libraries. So this is reverse engineering to figure out what is missing so I can compile the packages. So in reverse order, if you go further, this is a trick how to define cron repositories. If you're not R person, don't push. But if you're R person, then that sounds familiar. You get the cron mirror. And then what you need to do is, at this point, this is critical. You need to say to the configuration that you created for R, where the new libraries that you compile will be stored. And that's, if you look, this is a system path, but that one points to the container. So literally, when here, those are the lines that will install the packages in R. This is something that you will do either inside an R, or you will do it in a script, but you want to install DevTools, and I'm wrong, it was a bioconductor that was asking, so I was mistaken with this package, but this gives you an idea. Then DevTools will be used to install more packages, and this is the fix at the end. This one installs the latest RStudio, which is not available in Ubuntu 20.04 by default. Here is one fix, because the newer RStudio comes with sandboxing, platforms that are not. So you need to run RStudio with no sandbox. But if you build this container, okay, trust me, it takes like an hour to build it on a single CPU. It takes some time. When you run it, you have all the packages, everything set up, ready to use, plus a Python package, max2, which is also difficult to install. But now you have one file that you can give to your colleagues and say, get the shell inside or start the RStudio, which brings the R interface, and you can run the tools with the libraries available inside the container. Kind of really forced, isolated environment, almost just because R can't do it. Okay, there is a solution, but I find it cumbersome. And together with the Python solution, it won't work. There might be a possible way to solve that one with Conda, but for me, that was the easier way to do it. Okay, that was along the question about the extension. So could be anything. It comes from definition, but I hope you took a break. I didn't. Anyway, what I wanted to show you, the next one, is relevant if you want to run containers on Dardel. There, instead of a single file, and don't ask me why, I don't know the whole details, it's a different architecture. You need to come up with something which is called a sandbox. Starts to sound familiar, but essentially, if you're interested, go through the material. If you're stuck or something, contact us back. We will help you. Look also through the documentation of the PDC about that. But what is the message is that you can actually, this is something that I told you can't do. You can actually build the container interactively, which means that you start a sandbox. Everything that you do will be saved in an isolated file structure. So you can type, answer questions, bring files, copy files, back and forth. And at the end, when you stop, and this is read-write access. So let's say that you install something, at certain stage you need to fix something, and you don't want to do it with Z or command lines. You can open an editor, edit your files, add extra files, continue compiling them. At the end, you can just say, convert that one back to a single file, which is the story. For PDC or Dardel, you need to tar these folders and bring it to Dardel, untar it, and use it as untarred. But again, I will not go in details. I got the impression that some of your colleagues want to ask a relevant question or not. Okay, if it's not, I will skip that one. But this is exactly when, if you have many libraries missing, that might be the easier way, because you install something the way you used. It spit out an error and you fix it. You try to run it again, it makes another problem, you fix it, etc. That helps you to find a solution. But what I urge you is, like, what you want to end up, and the way it is organized is you take notes what you changed. So you want to end up with a recipe or a definition file, which you can actually run as a one-shot, because that's reproducible and it's documented. Everything else that you've done is probably you've been, yes, have a few more, because I now running Singularity container. So I already showed you, and let's stick to something simple. And then this one is the local. So if we run it the way which I showed you, like the container itself, it really depends what was in the container defined. Now I will actually mix, because I was bad with timing, what is in the container. And this is when it's crucial that if you build the container, it will document what you've done. So the easiest way is I will just Singularity, inspect. And I'm interested only of the definition file, so -d. And then it's, I mean, this is line by line, exactly the definition file used to run the file, to build the container. From that one, I can see what I've been, or what has been used or defined to run. Probably there are other options, I guess, all, let's say, that gets a little bit unreadable. You can find in a JSON format the information, but you can find more, not much. You get some environments and etc. Anyway, so it's a little bit like a black box, what is in the run script. If it's properly built, you will see it, but the equivalent is that one. This is absolutely the equivalent. And why it's done? Because it's probably to be similar like Docker. You have Docker run, and you say which container you can run. Now, why I brought Docker into this discussion? I mean, similar to Docker, you have Singularity exec. And then you specify the container. So I'm really serious. Here in Docker, it's not the image, but the container. And you are saying inside this container what you want to run. So in this case, I can say Fortune. And it will run only Fortune, nothing else. And the most common trick that you've seen also with Docker is to start a shell session, which is a bin bash. That was actually the shell command. Now, this also gives you an option that if there was a C shell, like T, C, or Z shell, you can get another shell into the container, not a bash, but some of the other shells. So that gives you also the options. Let me see what it will be. In this particular case, let's say Fortune, I can ask for help, actually. Yeah. So for the price of something like this, okay, I was referring to another case. If this was how you're supposed to run it when it was directly installed, like just Fortune H for help, you can just say Singularity exec in front of it, and then everything after it remains the same. This will be passed. If there were more parameters, let's say minus n. What is this number here? Let's say 4. What? Okay, I have no idea what n stands for. But if I run it on my computer, it would have been this way. So why it didn't work? In a sec. Let's see. It could be a different version. So I will not speculate. That's okay. I will back up on that. But this is how you will run it, and some examples around when you have like some tools, bump tools, or some of these bioinformatics, when you have a really long line with parameters. You just add the container and Singularity exec, and everything else remains the same. Then you run, but Fortune or the program that you started will run inside, well, inside the way you look at it, in the environment of the container. And this is how it is done with Nextflow and SnakeMake. You can say, execute this tool, but execute it with such a Conda environment or Singularity environment. I think they have even also Docker nowadays. Might not, but you immediately have to see the idea that they are similar with this respect. You have something that you want to execute, but before executing or run that command line or setup with the environment in this container. Extremely convenient, and for reproducibility purposes, it's an excellent tool. Then I have a short story. It was a project about, it was R again. It was a colleague at BMC here. They had a collaboration with UK on sensitive data, and essentially they got different results, and different enough so the conclusions are different. And trying to make Conda with the same, or saying, okay, in Bianca we say module load that, and etc. That doesn't work. So we spent like 3 months. Well, most of the time was spent on not making the environment, but small fixes, how to make it R behave nicely. But the result of 3 months work is like 10 gigabytes of container containing exactly like R setup with all the packages necessary and all the reference databases inside. And this is the first time when they were able to produce the same results here on Bianca and in UK, United Kingdom. So what can I say? It's worth trying it. Let me see if I have something that I forgot to mention here. Yes, bindleaf. I don't see other questions, but what happens is by default, if you don't fiddle with your configurations on your computer, by default, it will mount your home folder. And that one sometimes resides here, sometimes depending how you install it. And the easiest way to figure out where it is like you run Singularity. Build CFG. Here is the file in question. So if I look on mine, of course, and if I look for mount, so proc, you want to have that one. Sys, yeah, it's better integration with the system. Dev, home, here is the key point. By default, everything that resides in your home folder is also mounted, but it's a tiny one. If you share the computer, which means that you have a user using the same computer, it doesn't mean that you have their home folder, even if you have an access on the system. Now, on Rackham is semi like that, you want to projects, for instance, the only way we can look on that one, you're actually mounting the whole CREX where all the project data is located, etc. Important also, TMP is mounted. That's by default. Usually this is what you want, but in some cases when you want to achieve complete isolation, the most common, this is what is done in Nextflow, I know. They unmount home. They just say don't mount home, because this is how you can pollute your Conda or Python, probably Julia as well. So anything that tries to store files in dot or in home, usually hiding under dot somewhere, they will get inside the container, and instead of isolating the environment, they will pollute that environment. But saying that one, this is the point where perhaps the question is for Windows and Mac. If you find out where is the access to your folders, then you can mount it. I will do a really stupid trick. Let's see if that was that's the other. I will show it. For instance, let's say we're still in the local. But how about if I get a shell? Singularity shell. I'm guessing now, so let's see if this will work. I'm here, and I see exactly. Of course, I don't have aliases are not there. How about if I bring something here? Let's say -b, and then this is O Mitev SV, and then I put it where? Let's put it there. So on the left side is the folder on the physical computer, and where that folder will be available inside the container. So if I start that one, if I do LL, look at, I have that one, and it's actually on the root structure, and I own it. And if I see what's there, it's actually my Singularity collection. And I have actually remapped it to be on a different place. I have no idea if I can put it into even that folder. Let's see, this is probably won't work, but let's say, yeah, they want the absolute path. So this is the time when I want to tell you the other problem. So right on time. Absolute path is crucial if you use the container, and Rackham, for instance, is best example. Now, remember when I told you, when you're inside the container, you don't know anything about the module system. You don't know anything about the Slurm. You don't know about MPI and other, because they come with the module system. It's very similar that, for instance, your projects, they're symbolic links. Let me see if I can show you that one as well. That's my home folder. If I go to one of these folders, let's see, DVD, that is wrong. Exactly, it's a symbolic link. The real folder is here. Now, this is resolved by the symbolic links on the file system, on the hardware, or the real computer. There is no way you can resolve that one properly inside the container. So what is the messages? If you have files or symbolic links, they don't, it is very similar. On the hardware machines, you might have the same problem. Try to avoid symbolic links that crosses the file systems, which means that if you just link for a subfolder or somewhere in the same folders and things like that, that will work, because it's independent how the disk were mounted and etc. Now, if you point from your home folder to the projects folder, There is no guarantee that once you jump into the container, they will be mounted the same way. So you will have a broken symbolic. So the most common error is you have somewhere in the path, where is your binary? And because it's in a conda environment, it's a long path, and you created a symbolic link, and you have that one in the path. You jump in the container, you want to access that binary, and Singularity inside the container have no idea where to find where is this symbolic link points. So try to avoid, I would say, it's not the best disaster, but it's a good rule of thumb. Avoid symbolic links. And then it's like, if you are aware what it means that they cross the file systems, then you're safe. But in general terms, try to avoid. It's a hassle, but it could save a lot of time trying to figure out what's went wrong. Let me see, there was a question. Is it possible to mount a folder in the local computer on the Singularity container if we're using Singularity in a background? Yeah, probably, but not easy. You need to bring the folder when you start Vagrant to the virtual machine. Find out where that one was exposed to the virtual machine, and then you can mount it. So it's really a hassle. What can I say? It's in Swedish, I used to say something like kaka po kaka. It's like you have a virtualization inside virtualization. So it becomes a little bit messy, or at least it complicates. If you want to know what is mess is, let's say Docker, say they promote that one. You can install Docker inside the Docker image or container. Nowadays, you can install Singularity inside Singularity. I mean, in both cases, you're looking for troubles. But if this is what you need, it's probably you can do it. And this is the other point that I want to bring. There is because many people complain that they can't install Singularity. Somebody did installation in Conda for Singularity. So some rule or installations for SnakeMake or Nextflow in their environment or dependency list, they install Singularity from Conda. And that works for the workflow they have defined it, because they're sure that they're using containers that are capable to run in this stripped down, really squeezed of options Singularity. Now, if you have done that error, if you try to run generic containers, they will run to these limitations, and the error that you get back makes no sense. From own experience, took like 2 hours before we realized why this is not running on Rackham, and the reason was that the user had a Singularity in their Conda installation. So make sure you don't have something like that if you're messing with Conda. I don't see other questions, so let's try to finish the morning. After like 1:15, Pedro will take over, and he will talk about high performance or how you run parallel programs. I don't want to spoil it, but it's easy to run it on a single computer in parallel options, but when you want to run multiple, it becomes cumbersome, but he will talk. And then I believe we will have plenty of time after that to discuss anything that you are particularly interested or something was unclear. Then it's like, let's say, freestyle. So it could be anything. I mean, questions to Pedro, to me, or if it requires, we will just tell, let's wrap it as a support ticket or anything like this. Have a lunch, take some rest. There will be also feedback form that I will send probably this afternoon or tomorrow. Come on, we will be tired. But when we are back, you might have questions. So let's start with short questions to clear out, and Pedro will continue. Last questions before we go for lunch. Let's see. No, the bind -b bind is on the command line when you start it. The ones that we were looking also is like in the configuration file there with root. This one, if you mean this one, that is on the real computer. That's on my computer. On Rackham, we can let's see where it is. So that is Apptainer, and if we look, that makes sense. I will show you. So probably I need to update also that one. I will jump. So you see, let's see where is mount, slave, overlays. Yes. Oh, that's okay. That's here. It binds local time. Yeah, that makes your machine miraculously having the clock synced with your hardware machine. That will give a chance your Singularity is aware of what's around, what is defined as a host. Doesn't give you a guarantee you get everything, but it will know if you have, like, for instance, transit server. I think it's in the host file, so some goodies, not everything. There is a lot of things coming from the NIS network. Gosh, I forgot the abbreviations. Identity server, perhaps, network identity server. Proj, this is where you get your projects. This is where is the software on Rackham. Scratch points to a local hard disk. Krex, Dutra, and Domus. Those are another locations. Domus holds your home folders. Dutra is the paid storage project available to purchase. That's an advertisement on Rackham. And Krex is, well, to be honest, this is a subfolder on Krex, but those you get for free by default. You don't have to specify. They are mounted just because it makes it easy. Once you're in the container, it looks almost identical to how it looks like on Rackham for the physical machine. But you see, OPT is not there. I think on Tetralit, they are mounting OPT to expose the MPI, which makes a lot of trouble. I'm not sure if they gave up on that one, so it's not mounted anymore, but I can't give you. And this is the other one, which will see essentially the NIS or the network identity service, but might not work as well. So that one is not available. Does that make sense as a question? And okay, we start like 1:15.